Combustion and flame. Introduction. Burning of fuels and other substances is required in our day-to-day lives for various reasons. Example, in cooking food, running vehicles, in power plants to generate electricity, and so on. The process by which any substance or fuel burns in the presence of air with the release of heat and light is known as combustion. Combustion is an oxidation process because it cannot take place without oxygen. A substance that shows combustion is said to be combustible. Example, paper, wood, kerosene, and liquefied petroleum gas, LPG. A substance that does not burn in the presence of air is called a non-combustible substance. Example, soil, rocks, steel and glass. Conditions necessary for combustion. There are 3 conditions necessary for combustion. They are fuel to burn, air for the supply of oxygen, heat to start and continue the combustion process. Fuel is a substance that easily catches fire and produces heat or energy. Nothing can burn without oxygen. Heat is necessary to raise the temperature of a substance to its ignition point. Ignition temperature is the lowest temperature at which a substance catches fire. This temperature is different for different substances. Example, a piece of paper burns easily and very fast when lighted as compared to a piece of wood. This is because the temperature at which paper catches fire is lower than that of wood. Such substances with very low ignition temperature are said to be inflammable substances. Example, LPG, alcohol, and petrol. If the temperature of a combustible substance is lower than the ignition temperature, then the substance will not burn. Controlling fire. Fire is a very dangerous thing as it can spread very fast and easily in the presence of oxygen. It can burn anything wherever it spreads. At times, it could get out of control. Thus, we need to be aware of the ways by which we can control fire. In order to stop a fire, the very first thing to note is to cut the supply of oxygen. This could be done by several methods, such as putting water, sand, or soil, a blanket on it, or using fire extinguishers. Principles of extinguishing fire. A fire may be extinguished by removing all the combustible substances, cutting off the supply of air, that is, oxygen, reducing the temperature of the burning substances below their ignition temperature. Fire extinguishers. A fire protection device that is used to extinguish or control small fires is known as a fire extinguisher. It is a must for all the public places, such as movie theaters, banks, and offices, to have active fire extinguishers for the safety of people. People also keep small fire extinguishers at home as well. Types of fire extinguishers. Water fire extinguisher. The firefighters spray water to extinguish big fires. Water fire extinguishers are suitable for extinguishing fires involving solid, combustible substances such as wood, paper, and textiles. But it should not be used in putting off fire in electrical wiring or electrical equipment, as water is a good conductor of electricity and can electrocute the person involved. Soda acid fire extinguisher. The soda acid fire extinguisher is based on the principle of extinguishing fire by cooling the burning substances below their ignition temperature and by cutting off the supply of air. A soda acid fire extinguisher consists of a metallic cylinder having a knob and a nozzle tube. The cylinder is filled with a saturated solution of sodium bicarbonate, NaHCO3. A glass bottle containing concentrated sulfuric acid is kept inside the metal cylinder as shown in figure. When we strike the knob of the extinguisher, it forces the water solution out through the nozzle. The mixture of the liquid and carbon dioxide extinguishes fire. Other fire extinguishers that can be used are AFFF foam, carbon dioxide, ABC powder, and wet chemical fire extinguishers. Types of combustion. Combustion may either be rapid, spontaneous, or explosive. When a substance burns rapidly and produces heat and light, it is said to be rapid combustion. For example, burning of gas stove. When a material suddenly burns into flames without the application of any apparent cause, it is said to be spontaneous combustion. When fire breaks out suddenly with the evolution of heat, sound and light, it is said to be explosion. A large amount of gas is liberated in such a case. Flame. When a substance is burned, a hot luminous gas emerges out of it. This is known as flame. Some substances burn with a flame, while some do not. The substance which vaporizes during burning gives flame. Example, combustion of kerosene oil produces flame. In case of a burning candle, the wax melts first and changes into vapor. It is the vapor that burns as flame. Structure of a flame. If you observe a burning candle, you will observe that the flame is not the same throughout. It has various zones. The color of the flame is blue at the base, close to the wick. There is a zone around the wick, which is called the dark zone. There is a luminous zone around the dark zone. It is yellow in color. Then, there is another zone that is non-luminous. This zone is hardly visible. Now, we shall discuss about these zones in detail. A burning candle, in fact, has 3 zones. The innermost zone of unburned wax vapor. This is the least hot part of the candle. It appears black due to the presence of unburned wax vapor. The middle zone of partial combustion. This is the major part of the flame with moderate temperature. The unburnt wax gives out carbon particles, which burn to give yellow light and makes this region yellow and luminous. Outer zone of complete combustion. This is the zone where complete combustion takes place. This makes this zone the hottest one. The color of this zone is blue, non-luminous. Fuel. Fuel refers to anything that gives out heat and energy on burning at a moderate rate. Some commonly used fuels are coal, cow dung cake, petrol, kerosene, LPG, and CNG. The process of burning produces heat, which is referred to as exothermic heat and is used for various purposes. Characteristics of a good fuel. There is a wide variety of fuels available in the market. But what is exactly a good fuel? What makes one fuel superior to the other? The answers to all these questions are provided by knowing the characteristics of a good fuel. These are: it should not be too costly. It should be readily available. It should be easy to use and transport. It should have a high calorific value. A good fuel does not give out any poisonous chemicals, combustion products, or environmental pollutants. There should not be any problem to dispose of the end products of the fuel after burning. Calorific value of fuels. Calorific value of a fuel refers to the amount of heat liberated when 1 gram of a particular fuel is burned completely in the presence of sufficient oxygen. The calorific value of a fuel is expressed in a unit called kilojoule per kg. Harms of burning fuels. Some fuels release unburned carbon particles in the air. These particles can cause a number of respiratory diseases. Some examples of such fuels are wood, coal, and petroleum. Fuel calorific value kilojoule per gram. Cow dung cake 6,000 to 8,000. Wood 17,000 to 22,000. Coal 25,000 to 33,000. Petrol 45,000. Kerosene 45,000. Diesel 45,000. Methane 50,000. CNG 50,000. LPG 55,000. Biogas 35,000 to 40,000. Hydrogen 1,50,000. If a fuel is not completely burned, it releases carbon monoxide, which is a highly harmful gas. Inhaling this gas could be fatal. Most fuels burn to release carbon dioxide into the air. The increase in the concentration of carbon dioxide in the air adds to global warming. Fuels like coal and diesel release a suffocating gas called sulfur dioxide into the air. This gas is corrosive in nature. Oxides of nitrogen are also released into the air by petrol engines. These then result into acid rain. Acid rain is highly harmful to crops, buildings, and soil. Nowadays, CNG, compressed natural gas, is used in place of petrol and diesel. It is said to cause comparatively very less pollution.